Now there's a tricky one that I want to talk about. And this is our I3 minus. Now, I3 minus should have a total of 3 times 7 valence electrons plus 1, so 28. We have an iodine in the middle, an iodine on the right, an iodine on the left. So what I want you to do is I want you to look at your structure for your iodine. I want you to think, do you have the very best option? And if you have the best option, how many resonance structures could you make of that? So when we look at our iodine, we should have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, sorry, not 28. That should be 22. I was wondering why my math was off. So we've used up 12 more of those, so we should have 8 left over. Oh, not 8, not even. My gosh, my math is so bad. All right, so we should have 18 valence electrons there. We should have 6 valence electrons left over. Now it's making more sense. And so we are going to put those on our central one. And if we think about it, can iodine have an expanded octet? And the answer is yes, it can. So when we're going through and we're trying to look at these options, you might have also thought, well, why not have the expanded octet on one of those other ones? Why not double bond that out? Have something that looks like this. And the short answer is going to be, well, what do our formal charges tell us? When we're looking at our system, right now, this entire Lewis structure should have a -1 charge. And when we look at our formal charges, this one is going to be a 0. This is a 0. And this one happens to be a -1. If we move that over, this one becomes a -1. This one is going to be a 1, 2, 3, 4. A 0. And this one is going to be a 0 as well. So when you're doing your Lewis structures, you want to have that extra formal charge. We're going to try to place that onto our central atom. The reason why we want to keep just this one structure instead of with the double bonds is that those double bonds are harder in their strain, right? It takes more energy to make a double bond. And so it's harder for us to make that structure than if we keep them all singles. So that's why we would prefer them all being single bonded together instead of a double one, is because that double bond would shrink our bond length, which would make or require more energy when we're first starting. So keep that in mind as you're going through and you're evaluating your resonance structures. Did you have some where you have extra double bonds in there that you don't need?